And that invisible point is our supermassive black hole.
Yep.
So you can see now, right? Adaptive optics is insane.
Yes, that's a big deal.
The Earth's atmosphere causes the twinkling of stars because all the Earth's atmosphere has this turbulent packets of warm air and then cold air and highly dense and then lower dense. So the light is gonna start moving around before it gets to your detector,
interacting with the atmosphere on its way to the whatever you're capturing it with.
Yeah, exactly. And so the resulting disk of your point source, let's say if you're trying to look at a star, it's going to be 25 to 50 times worse than that theoretical limit. Okay. And so what we can do is we can do something called adaptive optics. We can correct by making a fake star. Here, what you're seeing is the Keck telescope, and there's two lasers pointing out at where the telescope is looking, and it's creating a fake star there. The trick is the following. You've got a fake star that looks like any other star, but we know that it came from our laser, so it should be stationary.
Right.
The star and the stuff that I'm looking at could be moving and it could have dynamics.
Right.
But I know that the laser that I'm pointing is definitely straight.
Right.
Right. And the laser is going through the same bit of atmosphere that the starlight is coming in. So if I can change, if I have some kind of deformable mirror, right, that is taking that starlight, and right in the middle, I have like little ways in which I can change the shape of that mirror in order to keep that laser stationary. That's going to cancel out the effects of that column of the atmosphere.
Makes total sense.
Right?
Because we have a fixed point that we control,
yes,
that then can remove the noise that comes from the atmosphere.
Exactly. And then we can finally get to that diffraction limit.
Got it.
Okay.
Yes.
We can finally get to what the telescope is truly capable of given Rayleigh criterion. And here what we're seeing is the center of our Milky Way in infrared. On the left is without adaptive optics, and on the right is with adaptive optics.
My goodness.
You can see the huge change. This is how Andrea Ghez won the Nobel Prize.
This is crazy. It's incredibly high fidelity comparatively.
Yeah. And here when you're looking at something called Sagittarius A star, and the stars around that compact object. And if we were to make a movie out of this, you'd see all of the stars going around an invisible point. Right?